is Micah from VEX U Cyber Robotics Club, and today I'm going to be going over computer-aided design file nomenclature. First off, what is file nomenclature? File nomenclature is a systematic approach to naming and organizing files in a consistent logical manner. It establishes clear conventions for how files should be titled, categorized, and/or versioned to ensure that team members can easily locate and identify and understand the purpose of any file within the project. Proper file nomenclature is essential for maintaining organization, preventing confusion, and facilitating collaboration across the team. We never want to end up with a situation like this, where everything's untitled and just a random number, or what often happens in CAD maybe is you name a part thing or thingy or whatever, and now it's thing 2, thing 3, or just whatever you feel like naming it, even if it is descriptive. It gets very disorganized very quickly. So this is a way to fix it. So how does our CAD file nomenclature work? We have a category code followed by a subcategory name, a series number, and any additional specifications, and then a version number as well. So the category code is the first part of the file name. Numbers 0 through 9 correspond to different broad categories: assemblies, custom structural parts, purchased structural parts, and so on. The subcategory name is a group of 3 letters following the category code. This is an all-caps abbreviation for the group of components or assemblies that will be grouped together, such as DRT for drivetrain, IDX for indexer, SCR for screw, WHL for wheel, etc. The series number is a group of 4 numbers following the subcategory name, separated by a hyphen. For most CAD models, the series number is simply assigned in the order of creation to make 2 different files distinct in the case that there are no other distinctions within the file name. However, for assemblies, the series number is used to encode additional information. The first 2 series numbers are used to indicate which robot design the assembly is made for, while 00 is used for all general assemblies. The last 2 numbers are used to indicate the order of creation of the model, just like a normal series number. Because there's no particular importance in the series number with the order of creation, users may choose to order the numbers by component size, say making a smallest spacer number 1 followed by number 2, number 3, up all the way up to the biggest spacer, or making the most important assembly number. Say you have a full drivetrain assembly, making that number 1 so it's easier to find. And then there's additional specifications. This is an optional measurement or other important piece of information tacked on to the end of a file name following a hyphen. All measurements have an abbreviated unit followed by the value. Examples are IN 2.75, say if the part is a 2.75 inch wheel, or MM 75 for a 75 millimeter stroke length piston, or T36 for a 36 tooth gear. An important piece of information can also be conveyed in an abbreviated form, such as LS for low strength shaft compatible, or HS for high strength shaft compatible. 3P, 6P, 9P for VEX Robotics tooth type could also be used. Then version number is automatically formatted as V, and then the version number by Autodesk Fusion. And this is updated with each file save, so as the user, you don't have to input any version number. That's automatically formatted. And the version number is separated from the rest of the file name by a space. Here's a table of examples below, excluding the version number because you won't have to enter that. And I'll be going over this more within Fusion. File organization. So all files are named accordingly with the file nomenclature and organized into their respective category folder, subcategory folder, and additional subfolders where it's deemed fit. Examples include separating drivetrains from different robot iterations or similar spacers within different outer diameters into distinct folders, just to help with some more organization. The file nomenclature system has been developed for CAD design and will make it easy to both understand the general purpose of a CAD model without needing to open the file and organize all of the files into an intuitive folder structure. So getting into Autodesk Fusion here, you can see all the different category coded folders. And so we have assemblies, custom structural parts, VEX structural parts, custom motion parts, and so on, all numbered. So here I'm going to go over how an assembly and some of its subcomponents are titled. So here we have 0 WHL-0001-IN 2.75, or you could read that as 0 wheel 01 2.75 inches. So basically it's saying that this is an assembly, so 0 WHL, so it's a wheel assembly, and 0001, it's the first in the series, which that number isn't very significant, and then IN 2.75, so it's a 2.75 inch wheel assembly. And then if we come to some of the components here, we have 4 WHL-0001-IN 2.75. So you can see here that this one is basically the same part, but it's just a purchased motion part. That's what the 4 category code means, instead of an assembly. And then we have 3 GER-0004 T36A. So let's go over this one more. This is a custom motion part, gear, series number 4 with 36 teeth, and A means that it's a custom gear with template A. So when creating different gears here, you need a special profile to match the other gears that it's going to mesh with. So when making one of those gears, it is made with a specific template, and all the custom gears in that template get the same letter attached to it, so A, shown here. So that's how the category code, subcategory name, series number, and additional specifications work. And then there's also the version number attached to each of these. So the version number is automatically saved by Fusion, and you don't have to worry about that. It's formatted and everything automatically. So here you can see we have a bunch of different folders, and these are not included within the file nomenclature necessarily, but they still are helpful for separating out some more assemblies and keeping it more organized. So let's hop into the 15-inch here and then into the drivetrain. So you can see there's a bunch of sub-assemblies for this one drivetrain, but I've renamed this drivetrain to the series number 1 so it goes to the top and it's easier to find. So opening that up here, you can see in the drivetrain, not only does this follow the file nomenclature, so do all of the subcomponents and the sub-assemblies. So for these drivetrain parts, it's not necessarily needed to have additional specifications or measurements. Like you could put left and right for the different side sub-assemblies of the drivetrain, but on other things like the nut here, it is by the specification here, you can tell it's a thin nylon. And so say you want to insert one of these components into your design, you can tell here that this is thin nylon by the thickness, if you've seen these parts before, because you won't necessarily have the thumbnail there. But you might ask, why not just title the part thin nylon? Well, it can get complicated when you have so many parts that you have to put into your assemblies. So it's very helpful to be able to name it in an organized way such that it can end up in a folder that's easy to find. Another thing I wanted to showcase here is the obsolete folder. Sometimes you'll have models which you design which you end up not needing or replacing with a different model, and so maybe you don't want to delete it or whatever, so just throw it in an obsolete folder and it can clear up these other folders a lot more. So lastly, let's just look in the purchased motion parts folder here. As you can see, we have a lot of different categories, which is fine. This helps keep everything organized because there's just a ton of parts. But I'll demonstrate here with the gears. We're using 2 additional specifications to help show what the part actually is. You see we have the teeth number followed by its high strength or low strength shaft compatibility, which helps you for when you're trying to put that part into your design of seeing what part you're actually using. So as you can see here in our inserts folder, we do use the additional specifications for what hole type it is. So there's round or hex for Versa hex adapters, or axle AXL for axle hole inserts. And so for this one, where these 2 parts might look identical except for their series numbers, it's not too difficult to just navigate to this folder when you want to insert one of those parts, and then you can insert it from here into your design. Well, I hope this video has helped give a good overview of how VEX U Cyber Robotics does our CAD file management, and hopefully you can apply it as well in how you're naming and structuring your files within CAD.